everyone, and welcome to another class of the FYB data analysis training. I'm very sorry for the unintended break, and I'm very happy to be back. A lot of things have been happening that want to stop the progress of the training, but I won't let that happen because I must finish what I've started. Okay, so let's get into today's class. Today's class will be about this aspect of this chart, and today's class we're talking about testing of association or correlation between variables. Now, if we are talking about two numerical variables, then that means we are talking about either Pearson correlation or Spearman rank correlation, depending on if the variables, if they are normally distributed or not, or depending on the measure of the on the scale of measure of the variable too. Why, if we are talking about association between two categorical variables, then we'll be talking about chi-square or Fisher's exact test, depending on whether some assumptions have we are made. So we have some research questions and hypotheses that will be guiding us on what we'll be doing today. So for example, we have a question about what's the relationship between social connectedness score and depression level. For social connectedness score, we have a variable that is called, I think, TOSC, and then we have that represent the total social connectedness score. We also have another variable that represent the total depression score. Then we have another variable that represent the total acculturative stress, and this actually refers to the stress that someone experience when they actually change environment, when they move to a different environment. Okay, so we want to see what's the relationship between these different variables. Is it positive, is it negative, and all of that. Also, we have some hypotheses, so we want to see the relationship between the different variables. Are they actually significant? Are they just due to chance? Also, we have these hypotheses here. There is no significant association between having a religious affiliation and being an international or domestic student. So why religious affiliation is a categorical variable. Also, this one also is a categorical variable. Also, that's the first column that signifies if a student is an international or domestic student. So these two variables are categorical variables, and then we want to actually know if there is any significant association between the variable. The other research question and hypothesis, they are about two numerical variables. So for them, we'll be using maybe Pearson correlation or a Spearman rule correlation, depending on if some assumptions are met or not. Why, for this one, since we are dealing with categorical variable, then we'll be talking about chi-square test. So for Pearson's correlation, these are the assumptions. So the two variables has to be normally distributed. Then the scale of measure, it has to be interval or ratio scale. Since we are dealing with numerical data, this has been dealt with already. Then for the normality, we have to actually use our normality test to check for that. So now I'll just move into SPSS, and first thing I want us to do is to actually try to visualize the relationship between those variables using scatter plot. We can use scatter plot to visualize relationship between numerical variables. So let's go back. The first one is talking about what is the relationship between social connectedness and then depression level. So for this, let's use scatter plot to visualize the relationship between social connectedness and depression level. Let's go to graph and then legacy dialog and then choose scatter plot. So we want a simple scatter plot. So for the x-axis, so this is the total social connectedness score and this is the total depression score. So let's just put either of them into either x or y axis, and then this is fine. Then we can click on okay. So this is the result of the scatter plot. So plotting total depression score on the y axis and then total social connectedness score on the x axis. Looking at this, I can see that there's a negative relationship between the two variables. You can see it's going like this. There's like a downward slope. Let's use Pearson correlation now to test for the relationship between the variables. So go to analyze, then correlate. So here choose by variate, and then also we need to bring in the two variables, so total depression score and then total social connectedness score. So Pearson correlation. Oh, okay, before we go for Pearson correlation, let's confirm that the two variables are normally distributed first, so, because that is when the assumption for Pearson correlation will be fulfilled. So to do that, we need to go to analyze and then descriptive, then explore. So then we need to bring in, let's bring in the two variables here. And then we really don't need to put anything inside factor list. For statistics, descriptive is okay. Then for plot, we need to check normality plot with test. This is what will help us carry out Shapiro Weeks test to test for normality. Then both is okay for this. Then click on OK. And then now this is what we need. Okay, so I actually went back to analyze, then still the same explore. So I went to check the plot and make sure that histogram is checked instead of stem and leaf. So, and this is because I want to see the histogram also. Now looking at the histogram, so this is the histogram for total depression score, and then this is the histogram for total social connectedness score. We can see clearly that this one is not normally distributed even before we check our test results. But looking at our test result now, our p-value is 0.000, and the conclusion for this is that the data is not normally distributed for the two variables. Now the null hypothesis for Shapiro-Wilks test is that okay, the data is normally distributed. So that means if p-value is less than 0.05, we have to reject that null hypothesis. Now that brought us to the conclusion that our data is not normally distributed, and because our variables are not normally distributed, that means we cannot use Pearson correlation for this. Let's look at the second question, which is about what relationship between the accurative stress and then the depression level. Let's check for the normality of these two variables also. So still the same process. I'm just going to remove total social connectedness score, and I'll pick the total, this one, that's the accurative stress, and then every other thing is still the same. Let's click on OK, and then we still have the same result that the data is not normally distributed. Well, that is okay. So either ways, I'm still going to show us how to actually carry out Pearson correlation and how to interpret it. For the first question that we have here, that is about relationship between social connectedness and depression level. So we are going to do the Pearson correlation for that so that I can show us how to do that. So go to analyze, then correlate, then by variate, then make sure Pearson is checked there. Then you need to bring in your variable into this box. So that's total depression score and total social connectedness score. What's inside the option? Well, I don't need this. Okay, then next thing is just to click OK, and then here we have the result of our Pearson correlation. And just as we have seen from the scatter plot, there's a negative relationship between the two variables, and then that Pearson correlation is actually also showing the negative relationship. We can see that the Pearson correlation value for the two variables is minus 0.552, which actually means that okay, there's a negative correlation because of the minus sign, right? That has answered our research question about the type of relationship between the two variables. The two variables have a negative relationship, but for the hypothesis, which is saying okay, there is no significant relationship between social connectedness and depression level among the students, we can see from this relationship that there is a significant relationship, because the p-value, which is this sig2 tailed, is 0.005, and because our p-value is actually less than the significant level of 0.05, that means we will reject the null hypothesis, and that will bring us to a conclusion that there is a significant relationship between total depression score and total social connectedness score. There is a significant relationship between total depression score and total social connectedness score. Okay, let's now look at the second research question, which is about relationship between acculturative stress and depression level. For this, let's actually create our scatter plot too. So to do that, graph legacy dialog scatter plot, simple scatter plot, and I just need to remove social connectedness score here, and then use this one. Okay, then okay, and then this is our scatter plot. Looking at this scatter plot, I can see that there's a positive relationship between total depression score and total acculturative stress. You can see the slope is moving upward. Because we know that Pearson correlation is not the ideal test for this, I've used the first research question to show us how to use Pearson correlation. So for this one, we'll be using Spearman-Rho correlation, and we know why we are doing that. So because the variables didn't fulfill the assumption of normality. So to carry out Spearman-Rho correlation, you need to go to analyze, then go to okay, you need to go to correlate again, then bivariate, and then put in your variables. Then instead of checking Pearson correlation here, I'm going to check Spearman correlation. Then I'll click on OK, and then this is what we have here. So we can see here that the correlation coefficient, that's the Spearman's rule correlation coefficient, is 0.433, and that is positive. So that is actually still confirming what is in this scatter plot, that there's a positive relationship between total depression score and total acculturative stress. And then the hypothesis is that there is no significant relationship between total acculturative stress and depression score. And okay, our result is actually telling us that there is a significant relationship, because at a significant level of 0.05, our p-value, which is the sig two-tailed, is less than the significant level, which will bring us to a conclusion that there is a significant relationship between the two variables. So as we have learnt before, carrying out correlation can tell us like three informations really. It can tell us, okay, if there's a the type of relationship, if it is positive or negative. It can tell us the extent of the relationship, telling us if it is maybe strong, weak, or very weak. So if you come here now, I have a table here, and if the value is, if the correlation coefficient is between 0.8 to 1, then that means it is very strong. If it is between 0.6 to 0. To this, that means it is strong. Then you can see all the range. For example, now this result for total depression and total acculturative stress is 0.433. So that means that relationship is what? Is moderate. So the interpretation for this now is that there is a moderate positive relation, there's a significant moderate positive relationship between total depression score and total acculturative stress. If we go ahead and check the one for this one, 0 point minus 0.552, to interpret this one now, so let's to interpret that one, we can see, okay, that falls within moderate also. So that one will be that there is a significant moderate negative relationship between total depression score and total social connectedness score. So that's how to actually carry out correlation. Either it is Pearson correlation or Spearman correlation in SPSS. Okay, so we are in Excel now, and why I'm not sure if you can carry out Spearman rho correlation in Excel. Maybe you have to use some special type of formula that you derived yourself. I don't know, but I know you can carry out Pearson correlation in Excel, and there are two methods. Okay, for the first method, you have to go to the data tab here, and then you have to go to the data tab, and then for the first method, you have to go to the data tab and then use the data analysis command also. But one of the things you need to do is that the two variables have to be beside each other. So for example, we have total social connectedness here, and then we have total depression here. The two variables need to be beside each other. You can do two things: either you copy both out and paste it in another location, or you make it to be beside each other. So I'm going to create a new column after I'm going to create a new column before this variable by using Ctrl Shift plus. Then I'm going to highlight this particular variable and just drag it to the new variable I created. So now the next thing is to go to the data tab and then click on data analysis, then choose correlate, then click on OK. And now the next thing is to select the range. So I'm just going to select the two variables that are trying to know their relationship. And then so column is okay since they are in different columns, not different rows. First labels in first row, that is correct because I have column headers here. Then it should display the results in new worksheet. That's very fine. So I'll click OK, and then this is the correlation, which is minus 0.5518. That was the same thing we got in SPSS. The SPSS is minus 0.552. So this is this is one of the ways by which you can carry out, you can get your Pearson correlation coefficient in Excel. Another method is by using the correl function. So that will be equals correl, like short form for correlate. And then you need to select the first variable and then select the second one. So for the first one, I'll just come here and select the total depression score. And then for the second one, I'll just come and select the second variable and then click on OK. And then this is the Pearson correlation. So that is it. If we are using GraphPad Prism, then for the type of table, you need to select the XY table. So I've selected the XY table and it's saying enter or import data into a new table. That's exactly what I want to do. And then so I'm just going to click on create. Okay, I need to select something here. Enter and plot a single Y. Yes. And then okay. So I'm just going to go to Excel to copy my data. Then I'll paste it here. I copied it without the column header and I'll just enter the column headers manually. To draw a correlation, go to analyze, then click on correlation, then click on OK. Then here we have some options to choose from, but this place is important and is asking us, do you want to do Pearson correlation or do you want to do a non-parametric one, that's like the Spearman correlation? So depending on what we want to do, we can choose any of these two. Then you can select if your test is two-tailed or one-tailed. So now let's just click OK, and then we have our results, same results that we have so far. The Pearson's correlation, the R is minus 0.5518, and then this is the p-value, which is actually significant. You can see it's already telling us that it's significant because it's less than 0.05. So this is how to carry out correlation. This is how to test for a relationship between two variables in GraphPad Prism. Now this x and y is actually very important. What you paste in x and what you paste in y, you don't just paste the data anyhow. Your x is the independent variable, while the y is the dependent variable. I feel it makes sense to actually put the total social connectedness score as the x and then total depression score as the y, because the way someone is connected to a society in a place someone is living can actually determine if the person is depressed or not. So if you look at it that way, then it will make sense to put social total social connectedness score as the independent variable, which is the x here. I hope you get that. Okay, so after actually doing your correlation and seeing that okay, there's a correlation between two variables, maybe you actually discover that there's a strong correlation between two variables. Another thing you can do for your analysis is to carry out a regression analysis to try to see, can I predict my my can I predict my dependent variable using my independent variable? Do you get? So even though we didn't discover a strong correlation here, I will still be using this example to show us how regression analysis works. And for this, we will be working with only simple linear regression. Even though from our first class we saw that okay, we can have multiple linear regression also. So to do this, let's start from Excel. I'm not sure if I've showed us how to create a scatter plot in Excel, but I'll be doing that now. So to create a scatter plot in Excel, you have to select the two variables, then go to insert and then select scatter plot. So now this is our scatter plot. This is our scatter plot that is showing that we're using to visualize total depression score and total social connectedness score. So I'm just going to, let's see, I want to move the chart to another place. I'm going to cut it and take it to a new sheet. I'll paste it here. So now this is the chart. So this chart now is similar to the same chart that we got for the variables in SPSS anyways. But to do like your regression analysis in Excel, so we can click on this plot and then you need to check this trend line. You need to check this trend line. Actually, the aim of the regression analysis is for you to get an equation that you can use in predicting your dependence variable, and this equation will be in this format: y equals mx plus c, where m is the slope of this trend line and then c is a constant. So to get this equation in Excel now, the first thing you need to do is to add the trend line, and then the next thing you need to do, so I just click this plus, and then for this trend line I clicked on this, then I clicked on more option. So this is linear, and then click on display equation on chart. So I've clicked on that, and this is the equation now. So this equation now, this is the equation for our regression analysis. So if you need to predict, trying to make that bigger, if you need to predict y now, which is our total depression score in this case, using our independent variable, which is the total social connectedness score, then you can use this equation. But we don't just jump to predicting using like the equation. We have to know if this we have to know something that's called the r squared, which is what will actually tell us maybe how strong, or let's say how useful our regression model is. So you can also refer to this equation as the regression model. So to do for that, I'll still click on the line, then come here and then this, and then still click on more option. Then I want to check this display r squared value on chart. So this is the r squared value now. The r squared value is 0.3045. Now the interpretation of this is that the explanation of this r square is that just 30%, about 30% of the variability in the dependent variable can be explained by the independent variable. So that's actually quite small. So the regression analysis can actually be used if our r square is around 0.99 or 0.98, then that would be a very good model. That would be a good model that you can use for prediction. But this one is not. But this is just a way of showing us how to do your regression analysis, how to do simple linear regression in Excel. Another way to do your simple regression analysis to do your regression analysis in Excel is by also using the data analysis command. So come to data and then choose data analysis, then click on regression. You scroll down, then you see regression and click on OK, and here we have to select the y and x variable. So for our y variable, that is the dependent variable, and that is the total depression score in this case. And for the x variable, that is the social connectedness score, and that is the independent variable. Okay, I think there's a mistake right there. So for the For the y variable, that is the dependent variable, and that is the total depression score. And for the independent variable, that is the x, that's the x range here, and that is the social connectedness score. So I selected it with column header, so I'm going to check labels, and it should give me the results in a new worksheet. That's very fine. I'm just going to click on OK, and then this is what we have. This is quite more than what we have in the graph. Let me see. I'm just going to copy the graph and then paste it here. So here now we can see some things, but so this is the output, and here this output is more comprehensive than just using the graph and then fitting an equation for the trend line. But we can see some information that we are familiar with, like the r squared value. Yeah, so we can see the r squared value. Yeah, that's the same thing. Then we can also see our coefficient here. Yeah, that's what made up the equation. So minus 0.296, that's it, and then the intercept, which is the constant, that's 19.282. So if you are going to do your analysis using this, then you know that okay, the equation, the linear equation, the format is y equals mx plus c. That means you are saying okay, that means total depression score equals 0.2961 multiplied by this one, then plus 19.282. That will be the equation. I hope we get that. This other information here, we also see the same thing in SPSS, and then I will explain better in SPSS. So we are in SPSS now, and to do the same thing we need to go to analyze, then regression, then linear, and then here where total depression score is the dependent variable, so it is here in this box. And for the independent variable, this one is already here also. So statistics, fine with this. Then plots, I really don't want any plot, so let's just click on OK, and then we have these outputs that is similar to what we have in Excel, but still the same thing. We can see the constant, the intercept, which is what, 19.282, and we can see the coefficient of x, like the coefficient of the independent variable, which is minus 2.96. And using these two, we can come up with our regression model or the regression equation. Okay, and then this is the r squared value here also. So also along with the test, it also indicates if okay, the values are significant or if they are not significant. So here we can see the p-value here is 0.0042, which is showing that okay, those values are actually significant. Okay, I will advise that we actually still go online to read more about how to interpret all the different values that we can find here. Just a simple Google search will actually help us with that. So finally, let's just go to GraphPad Prism to see how we can do the same thing. So here now also you need to go to analyze, and then this time around you need to choose linear regression. That's checked already. Then click on OK, and we have this here. So we're also just going to click on OK, and then we have our output result. So here now we have the slope, which is this. We have the y-intercept also, which is this. So using these two, you can come up with your equation. Where is the r squared value? Here. Okay, this is the r squared value here. We have the r squared value here, and this is also telling us okay, if the slope is significant and all of that. We saw that in SPSS too. And then this is the equation of for the model. So this has given us the equation. So that's how to actually carry out simple regression analysis and how to interpret your results. For the last hypothesis, we want to know if the hypothesis is that there is no significant association between religious affiliation and being an international or domestic student. So these two variables are categorical variables. That is the we are talking about the interdom variable and then the religion variable. So for this variable, the test we can use is the chi-square test, because we are talking about two categorical variables and we want to know if there is association between the two variables. For chi-square test, the assumptions that should be fulfilled are these. So both variables are categorical variable, independence observation that is fulfilled, then expected frequency should in each cell should be 5 or more. So we will know this after we've run the test, and this particular assumption is not fulfilled, then we'll use Fisher's exact test instead. So let's go to SPSS and just carry that out now. So to do this, you need to go to analyze and descriptive, then choose cross tab. So analyze, descriptive, then how am I doing? Go to analyze descriptive statistics, then choose cross tab, then here bring the one variable into row and then the other into column, and then under statistics you need to check chi-square and click on continue. Yeah, that's fine. Then if you want to see the chart, you can check display cluster chart, then click on OK. Then this is the cluster chart, and then if you come here now, this is the cross tabulation. Why this is the result of our chi-square test. This um asymptotic significance two-sided here. This is the p-value, and if you look at this way now, Pearson chi-square, this is our p-value, that's 0.044. That is less than the significant level of 0.05. And what is that telling us? That is telling us that that we should reject the null hypothesis, which means that there is a significant association between the two categorical variables. You can see something here that zero cell have expected count less than 5. So that's the assumption about each each of these cell here is what we are talking about. So since none of it has count that is less than 5, that means that particular assumption has been fulfilled. But what if that assumption was not fulfilled? What you would do is to go to analyze, still the same process, cross tab, and then this time around you click on exact and then check this exact here, and then click on continue, then okay. So here in our results there will be like an extra line. So for our results now, the for our result now, this Fisher exact test, this particular one, would have been what we will use for the p-value if that particular assumption was not met. So this is the end of today's class. I hope you enjoyed it. We learned about Pearson correlation, Spearman correlation, chi-square test, regression, and how to do all of this in Excel, SPSS, and GraphPad Prism. So this is really the end of this is the end for treating different topics or different individual data analysis concepts. Yes, though I'm still going to release a video on chi-square where we explain deeply the theoretical aspect. So still expect that video. But as from tomorrow, we'll start actually going into project. So for the next class, we'll talk about, we'll analyze a survey data, that particular survey data that we filled. I sent the survey link that everybody filled. So we analyze that. So and then we also analyze like a lab result, like a result that is gotten from the lab, and then that will be the end of the training. So I hope you enjoyed today's class. See you tomorrow.